Hello, Professor Sargent here with you, and this is going to be our first attempt at a flipped classroom for Math 101. Let me first share with you what our objectives are for this lesson. All right, here we go. The objectives. We're going to learn how to write equations of lines in three common forms. Write equations of horizontal and vertical lines. We've actually done some of that already, but we'll get that tied in with the more general case of diagonal lines. Write the equation of a line parallel to a given line or perpendicular to a given line. And finally, look at the equations of lines that model real data. So, first of all, we already know that we can calculate the slope of a line if we are given the XY coordinates for 2 points on the line. Notice that I put there in green what is known and what is unknown, in this case in red, and that's what's being calculated. Okay, well, we also have already seen that if we know 1 point and we know the slope, now those are marked in green, that was enough information to graph a line because we could use the slope to tell us how to move to a second point. In fact, that process could be repeated so that we could move to infinitely many other points besides the quote starting point. There is no real starting point on a line, but the point that we first plotted, x1 comma y1. Turns out that having that information is also going to be enough to write the equation of a line. If we know 1 point, x1 comma y1, and the slope, that's going to be enough. And how can I make this claim? Well, now if we put the x1 comma y1 in green as something known and the slope as something known in the slope formula, well, all we need to do is cross multiply to get rid of the fraction, and that's going to give us this. That form of the equation of a line is known as the point slope form. Furthermore, two things. Number one, I've left in red x and y that have no subscripts. This means this could be any other point on the line. Any other point on the line, because we know the slope and 1 point on the line. It could be any point for x1 comma y1 as well. x1 comma y1, the known point, that doesn't have to be a special point. However, if we plug in the y-intercept where x sub 1 is 0, and let's call the y-coordinate of the y-intercept, let's call that b, so that 0 comma b is the y-intercept. Then when we plug in 0 for x sub 1 and b for y sub 1, do a little simplifying here. We don't have to distribute m because we know what happens when we subtract 0. X minus 0 is x. And then isolate y by adding b to both sides. What we get here is an equation of the line where y is isolated and it's mostly dependent on the slope and the y-coordinate of the y-intercept. However, that's a lot to say out loud. It's a mouthful. So instead of saying slope, y-coordinate of y-intercept, we just call this the slope-intercept form. And as for the different forms of equations of a line, here's our last bit. Another frequently used form is the standard form, where the x and y terms are on the left-hand side, with x being first. A, B, and C generally we say they're real numbers, but for right now, we're going to be more specific and say that they must be integers. We could in general have positive and negative, but no decimal or fraction part. However, in this textbook, we restrict A to having a positive value. So A is positive, and otherwise positive integer for A, and the rest have to be integers, no fractions or decimals. Notice also that that capital B over on the left-hand side, that is not the same as the lowercase b that represented the y-coordinate of the y-intercept. So what can we do with this information about point slope, slope-intercept, and standard form? We're going to find out with some examples in a moment. Okay, here's our first goal, to write the equation of the line passing through the point -6, 5 with a slope of 1/3. M is 1/3. And we need to write this in both slope-intercept form and in standard form. I'm going to start, however, with point slope. And so again, the slope, that's M is 1/3 going here. And then -6 is x sub 1 and 5 is y sub 1. Notice that I put parentheses around the -6 because I'm subtracting the -6, which is going to turn that x minus -6 into x plus 6. Next, you could distribute the 1/3 before getting y alone. However, I'm going to try to make this a little bit easier for us by multiplying both sides by 3, although there is something we need to be careful about in that case, which is also an issue of distribution. Now, technically here, I didn't need to still have 1 times parentheses x plus 6, but I do need the parentheses around the y minus 5. I'm going to distribute that 3. Distributing 1 on the right-hand side isn't going to change anything. So here's the results of the distribution. And then I could add 15 to both sides so that the y term is isolated, not y itself, but at least 3y. As for slope-intercept, I need to divide both sides by 3. Now, since dividing by 3 is the same as multiplying by 1/3, besides the fact that we've canceled the 3 on the left-hand side, so that 1y is alone, over on the right-hand side, dividing by 3, same as multiplying by 1/3. Not that I would normally write this, but it's what this looks like. You'd have to distribute that. In other words, divide the x by 3 and the positive 21 by 3. And here's what that's going to give us. Now we can tell that the slope of the line is 1/3. Well, actually, we already knew that. But furthermore, now we can also tell that the y-coordinate of the y-intercept is 7. You could also go back and plug in that point. 1/3 times -6, that's -2. -2 plus 7 is 5. So we do have our answer in slope-intercept form. As for the standard form, since I mentioned earlier that the standard form, we're being held to a rule about A, B, and C not being fractions or decimals, number 1, and number 2, that A be greater than 0, i.e. A has to be positive. What I did back here to get rid of the fraction for a little while at least, now I can rewrite that, subtract x from both sides. So it's no longer on the right-hand side. However, A is not supposed to be negative. So if I multiply everything on both sides by -1, that's going to give me x minus 3y equals -21. On that, that's harder to tell what the slope is, but we could take -6 minus 3 times 5. -6 minus 15 is -21. So we know that that point is on this line, x minus 3y equals -21. And so I started with point slope because this was not the y-intercept. I know that because x was not 0. It was -6. Would it have been possible to still start with the y equals mx plus b slope-intercept form and solve for b? We're going to try to address that in class tomorrow. So one challenge I'm leaving for class time tomorrow is that although we did not have the y-intercept when we started out the previous question, could we, since one of the ways we had to write the answer was in slope-intercept form, y equals mx plus b, could we have solved for b? That's one challenge. Now the next challenge is here, instead of being given a 1 point and the slope, and still neither one of those has an x-coordinate of 0, so neither one of those is the y-intercept. We're missing the slope, but we can calculate the slope, number one. And then number two, now that we've got the slope and 2 points, doesn't matter which point we use. I'm just going to use one of them, and I'll leave it as a challenge to address in class time. What if we used the other point instead? Now, one thing that should suggest that the answer to that is no, it does not matter, is it doesn't matter which one is the first point and the second point when I compute the slope. Because if I switch the order, that would switch the order of the subtraction in both the numerator and the denominator when we calculate the slope. All right, so I'm just going to go in the order that the points were presented, called the -2, 5, my first point, i.e. x sub 1, y sub 1, and oops. Then that second one I'm seeing my second point, which means the 11 is y sub 2. I've got to subtract from that the other y coordinate of 5. And since -8 was paired up with the 11, start with the -8, subtract the -2. So 11 minus 5 is 6. -8 minus -2 is the same as -8 plus 2. And so that's 6 over -6. So the slope is -1. And I'm going to plug that in to the point slope form, as well as, like I said, I'm using the -2, 5 as the first point. So, whoops, y minus 5 there, and x minus -2 here. Now, that's going to have the x minus -2 become x plus 2. And then I will still have to distribute the negative. So we will have y minus 5 equals -x minus 2, because we changed both the signs. We have to distribute fairly to all the parts. And finally, to get our answer in standard form, I will, first of all, add the x to both sides. And actually, you could combine these two steps. I don't mind if two steps of algebra are combined, But more than that, and I get concerned about jumping too much, and do you really know it? X plus y equals 3 because -2 plus 5 is 3. I can plug in -2 plus 5 here and get +3. -8 plus 11 is also +3. So both of those points are on the line that goes with that equation. Here are two questions that I would like to only take a quick look at. However, if my explanation does not completely convince you, it's something that we can discuss in class time. On these two, I don't think any work needs to be done. When you have a slope of 0, that's because it is horizontal. Y is not changing. X1 and X2 would be different, so you're dividing by something other than 0. 0 divided by anything else is 0. That's happening because we do have a run, but no rise or no fall. So this is just another way of saying that it's horizontal, and that means that y is going to stay the same. So the equation of the line is y equals 5. We don't need to use any of the approach shown earlier in this lesson. And so similarly, with an undefined slope, that means that it is vertical. And so y could be anything, but x is going to stay +5. So let me just copy this stuff and make a little change here. X equals 5 because this is a vertical line when we are talking about the slope being undefined. I think we just have one last thing to look at here. What's wrong? We have two things. So first off, parallel lines and perpendicular lines. Two lines are parallel if their slopes are the same, but their y-intercepts are different. And why is that? Well, if their y-intercepts are different, they're definitely different lines. And if their slopes are the same, then you're going to be moving the same way, but you had different, quote, starting points with the y-intercept. So how could they ever cross, which is the geometric definition of parallel? They never cross. Another way of putting that is m sub 1 equals m sub 2. Two lines are perpendicular, though. Perpendicular. If their slopes are negative reciprocals of each other. What that means is that if we take the slope of one of the lines and both change the sign and flip the fraction, then we would have the slope of a perpendicular line to the first line. That is equivalent to saying that if we multiplied the two together, that their product would be -1, because the fractional parts would cancel out, but they're opposite signs. So m sub 1 times m sub 2 would equal -1. Let me find an example here real quick. Okay, I'm going to leave the bit about when the two lines are supposed to be perpendicular for an example we'll work on together in class time. Let's just take a look at writing the equation of a line that goes through the point 8, 5 and is parallel to the line 2x minus y equals 7. As with the first example, we're going to write the answer in both slope-intercept form and in standard form. So first off, although we're given a point 8, 5, we don't know the slope of the second line. What I just copied there is our first line. And if I subtract 2x from both sides, Don't forget that y was had a -1 for a coefficient there. So if I change all the signs on both sides, that's giving me that y equals 2x minus 7 is the equation of the first line. And now that tells me that the slope of that first line is going to be 2. So when I go to write the equation of the second line, say I start with the point slope formula. Give me a moment here. Yeah, y minus y sub 1 equals x m times the quantity x minus x sub 1. Okay, we're going to be working on getting the equation of line 2 now. Then I can put in the 2 as well as the point 8 comma 5. So x sub 1 is 8 and y sub 1 is 5. So I'm going to distribute the 2. It's nice that it wasn't a fraction. And then 2 options here. 1, to get it into standard form, I would have to add 5 to both sides, which would give me negative 16 plus 5 is going to be negative 11. That would complete the slope-intercept form. And checking, that does have the same slope as the first line. Furthermore, 2 times 8 is 16. 16 minus 11 is 5. And then I could go back to this. Since I want, in standard form, I want the coefficient of x to be positive, I'm going to subtract y, get rid of it from this side, and add 16 to both sides. I can get it to copy. All right, so 2x minus y equals negative 5 plus 16, which means that negative 2x minus y equals negative 11. Harder to see that that has a slope of 2, because we can only tell the slope by looking at what's in front of x if y is isolated, a positive 1y. But in any case, 2 times 8 is 16. 16 minus 5. Oh, I added positive 16, so that should be a plus 11 there. My error. Okay, one last thing to look at. Here we go. I'm going to take a look at 2 things regarding writing equations of lines to model real-life data. X represents the number of credit hours taken at a community college at $150 per credit hour, and Y represents the total tuition paid for the credit hours in dollars. So what we're going to be asked to do is to write an equation in the form either y equals mx or y equals mx plus b. In this case, it's just going to be y equals mx, because if you don't take any classes, if you have no credit hours at that community college, then you shouldn't be paying anything. Now, notice how they said $150 per credit hour. Give me a moment here, switch over what's being shared. Okay, hold on. rather than thinking of writing equations as something magical, in the case of this real life application, think of something that makes sense. The dollars per credit hour times number of credit hours is going to be their total charge. X was the number of credit hours, and Y would be their total charge. We knew that there was $150 being charged per credit hour. So our equation is Y equals 150 times X. So similarly here, we've got a health club membership costing $99 plus 41 per month. Well, here you're not starting at the origin, 0, for our y-intercept. Anyone that has a membership is going to start out at $99, and then for each month, $41 per month times the number of months. So if X is going to represent the number of months, and then Y is the total cost in dollars, we're going to have 41 times X plus 99 equaling Y. So let's see what that looks like. So again, we have that starting point where it was $41 per month, but also that there was that base fee of $99 that they're going to pay right to start with. And then we add on 41 per month. Notice how I didn't write 99 plus 41x equals y. I put it in that order so that we'd see it in slope intercept form. That's all for now. See you in class.